Okay, so here's your completed table with all the pairs of numbers that you need to add to the adds column and multiply to the multiplies to column, right? For example, we can say 3 times 5 does give me 15, 3 plus 5 does give me 8. And again, these bottom ones where we're starting to get into looking for negative products and negative sums are a little bit trickier. So take a look at the table if you want to pause and see how my answers compare to yours and if you were able to successfully get all of those results. Okay, so we're going to use this skill now in order to do factoring. Okay, so if you want to factor a trinomial that's in this form where there's an x squared, a bx, and a c, we're going to actually use that skill that we just talked about, where we're going to find numbers that multiply to the c value, and the same two numbers need to add up to the b value. So when we talk about b and c, you can take a look at the form, and it looks like b is the thing that's in the middle that's attached to x, and c is the term at the end that's by itself. So we're going to find things that multiply to the end result and multiply to the middle. Right? So I want to show you again what factoring means before we get into some examples. What we already know how to do is simplifying, which means if I asked you to multiply these two together, you would do the double distributing that we've talked about, and you would get this result, x squared plus 9x plus 14. And if you want to do that on your own to get some practice and check to see that you get that this result, that's a great idea. Okay? If you notice in the what we're going to do now side of the page, I'm giving you instructions to factor, and I'm actually giving you x squared plus 9x plus 14. Right? So we're going to take this answer to our multiply problem, and our job is going to be turn it around and give me the two factors, x plus 7 and x plus 2 is what we had in this case. Right? And so the real challenge is figuring out, well, what were those two polynomials? How do I turn x squared plus 9x plus 14 into these pairs? Okay? So if you notice, the c value here, as we talked about at the top, is 14, and the b value is 9, and 7 times 2 gives me 14, 7 plus 2 gives me 9, so that's how we're going to figure out that pair of numbers. Right? So seeing these side by side, you can see when I ask you to simplify, we're putting them together. When I ask you to factor, we're going to have to figure out how to take this apart and make it into two or more expressions. All right, so let's use this skill and try to apply it a little bit. Okay, so this example here, I'm giving you the expression x squared plus 8x plus 15, and I'm asking what two expressions did you multiply together that gives you this result. So our job is going to be figure out numbers that multiply to 15. This is always going to be my multiply number at the end. Okay? And the same two numbers need to add to the middle one, which is the 8x right here. So this is going to be my add number. Okay? So I'm going to say, can I find a pair of numbers that multiplies to 15 and adds up to 8? Well, if I'm thinking about it, again, if you're stuck, come off to the side and say, okay, well, I can do 1 and 15. I can say 3 and 5. Okay, well, it looks like I ran out. That's the only pairs of numbers that give me 15. And there, that bottom one, 3 and 5, that's going to be the pair that adds up to 8. So I'm going to set up two parentheses, one for each of the factors. And this x squared gets split up, so I'm going to say put one of the two x's here and put the other one in the second parentheses. And the pair of numbers that I find, 3 and 5, this is a positive 3 and a positive 5. So I'm going to put those numbers right into the parentheses, and I'm going to say x plus 3 times x plus 5. Well, that's going to be my pair of factors. Okay. So again, the challenge is really just going to be once we start getting down to these negative ones, can you continue to find that pair of numbers? So with 24, I'm saying, again, this is my multiply. I'm going to use the m. And negative 11 is my add. So I'm going to say, what are the factors of 24? Well, I'd say 1 and 24, all right, 2 and 12, 3 and 8, 4 and 6. And those are all my pairs of factors. I need ones that that add, in this case, to negative 11. Well, the only way that I can have a positive product and a negative sum is if they were all negatives, right? So all of these are actually going to be negative, negative, right? That still multiplies to 24. But now I'll get a negative sum, right? So I'm going to put negatives on all these. It's the only way that I can get a negative sum but have a positive product. Right, so now when I look at it, I say, oh, look, right here, negative 3 plus negative 8. Well, that's going to give me a negative 11. But when I multiply them together, I do still get the positive 24. So again, let's set up y minus 3 and y minus 8. Right? So one more example down here. I got a couple to try. All right, so again, negative 15. If I'm thinking about the factors of that, I'd say 1 and 15, and I'd say 3 and 5. Okay, but I need a negative 15, so there's actually two possibilities. There's negative 1 and positive 15, or there's negative 15 and positive 1. And the same thing down here, I could have negative 3 and positive 5, or I could have negative 5 and positive 3. So there's actually an extra pair for those negatives. So I'm looking for the pair that multiplies to negative 15. All of these work, and then in this case adds up to 2. Well, this third one here, negative 3 plus 5, that's going to be positive 2. So I'm going to say A, and I'm going to say minus 3, and then A plus 5. Okay? So your last one, I'm just going to give you the answer for, and you can go through and think about why that's correct. I'm going to say in this case C, and I need to get numbers that multiply to negative 21. Well, it looks like it's going to be minus 7, and C plus 3, and that works for this one. Okay, so there's going to be some examples to try to do this.